Okay, so yesterday we looked at how we could set a table up so that you could actually chart the values of x, and rather than string out all your probability things, you can work them off your table. So that's our goal, to make a probability distribution function. From this table, you could also make your graph, your probability distribution graph off of this. That's your P of x. So your problem says you're surveying a whole group of retired people, and you have to look at your graph. You ask 7 random people if they used retirement as their source of income. If they use their, if they use their pension as a source of their retirement income. Now, those are the random 7. I want to know what the probability is that out of the 7, 0 say yes, they use their pension. 1 says yes, 2 says yes, 3 says yes, all the way up to the lesser to 7. So you have to look at your chart. You're going to do this 7 times. Your probability of success is 34%. Take it off the graph. Your probability of failure is 1 minus this. And we can do this in any order. Like the first one can say yes, the first 2 can say yes, or the last 2 can say yes, the middle 2 can say yes. We know we have combinations. Your chart says 0 to 7 because 0 people can say yes. Remember, these are the 7 at random that I choose to ask. The probability is almost close, is about 1/3. It's about 1/3 of the time they will say yes. So if I expect all 7 people to say yes, it will be very rare that all 7 people will say yes. Now, you have to know how to do this. Whether you use the combination one or you use the binomial PDF, you have to know how to do this. And I'm going to show you what the CDF means in a minute. The PDF, if you use binomial PDF, it kind of makes sense because this is a probability distribution function for a binomial. Even though that graph gave them a multiple things that they could respond yes to, all I want to know is, did you say yes to the pension or no? So it's only 2 choices they get to say, based on the track of 34%. So if you use your binomial PDF, and I think all your calculators now are updated with the new software. If they're not, let me know. It's going to say trials. How many trials did we have? 7. That's the same as our N. It's going to say P. That's your probability of success. Make sure you use a decimal point. And it's going to say X. This is the value that you chart through your table. Start with the 0 and paste it. This will do exactly what the 83s do. And the 83s or anything without the software will have you put this in order. N, P, X. It goes alphabetically. It will do the N, the P, the X. Once you do this once, second enter. Don't go through the binomial PDF again. It's like your information is still there. You're still only changing 1. But just do second enter and change this one. Keep your probabilities to 3 decimal points, unless you need a significant digit. Now, there's only one that's going to give you a hard time, and that's the last one. And when you do that last one, if you get 5.4 to whatever it is, E negative 4, that's your scientific notation number. That says, I have a number. You certainly know that probabilities can't be greater than 1. We have a number that I'm going to have to move my decimal point 4 positions to the left. So when I move this 4 positions, I get 0.00054 something. At least round to that 5. Don't give me 0, because remember with the 0 means that it's impossible to happen. So you don't want to leave it at a 0. If you use your combinations, and you want to use, it's Bernoulli's combinations, he's the one that invented this. See, we're doing 7 things, 0 at a time. My probability of success and I want 0 of these, my probability of failure, and right now I want 7 of them. That's how to start. You can also do second enter. However, you have to change this one, this one, this one. You have to change it in 3 places. Because the next one will be C7 1, 0.34 1, 0.66 6. You'll have to change it in 3 places. Right? Which whatever your preference is to do this is fine with me. Give the binomial PDF a shot because it seems like where am I going to find this? How am I going to remember this? We do actually use a lot of those steps in there, a lot of those functions in there. So you'll be kind of used to seeing those. Varies, think of variables, and you'll kind of get to that, either hitting that or second that. So you'll eventually find it. Can everybody find these? Anybody having trouble doing them? You guys that were out? See what we're doing? We're just creating a table of each individual one. So when you put your values up here, make sure you get all these. Everybody get those? Now, what should the total of this column be? 1. All your probabilities have to add up to 1. That still holds. To be any kind of probability function, my probabilities have to be between 0 and 1, and my sum has to be 1. To be a binomial probability function, I have to have 2 choices, a success and failure, n amount of trials. My probabilities have to stay fixed, and I have to be able to chart my x random variables. So you got 2 separate things, a probability versus a binomial probability distribution function. Now, this table works really nicely now that you have all your information. And then you say, what is the probability of exactly 3 of those 7 saying yes, they use their pension as a source of retirement? You come here, and it's right here, 0.161. About 16, 261? 261. 261. About 26%. Now, notice your probability is about 1/3 of the time. To get everybody to say yes using a 1/3 probability is really rare. Somewhere in here, my probability is going to be a little bit higher. If my probabilities are small, the higher one stays closer to the top. If they're larger, the higher one stays closer to the bottom. It's like the tail with the skew in it to see where your probabilities go, and we'll talk about that probably tomorrow where your skew is. Today I kind of just want you to get a feel for working with this table and see where we go from there. Sometimes you can say this: find me the probability that at least 4 said yes. So at least 4 means which ones am I looking at? 4, 5, 6, 7. All I have to do is add these up. They're already on my table. So now if I say add them up, if I say what is the probability that less than 4 say yes, that's these guys. I could even do my complement case. If I added this up, I could do my 1 minus that because it's my complement case. See it? Now, there's a function right under your PDF, and it's called CDF. Let me explain what the CDF does, and we'll give it a try. Binomial CDF. What do you think the C stands for? Combinations. We're in the combinations, but a little bit different. We're cumulative. We're accumulating this. This is my cumulative one, but we are doing combinations with it. What this tells me is this. Say I want the probability that 4 or less, say yes. I can come here and pick my 4 or less and add them together. So add them together for me if you would. Try that. Add them together, tell me what you get. Everybody come up with a probability? Four or less? Did you get this? Yeah? Okay. I added up 4 or less. 4 or less. I added up all of those. Now, let's go to the cumulative one. What it does is it accumulates from 0 to a stopping point. It always goes from the 0 to the stopping point. So do your second bears and come down to the CDF, right past the PDF. It still sets it up the same way. Number of trials is 7. Probability of success is still 0.34. Your X value is what you want to accumulate up to. So we're going to put a 4 in there. And we're going to paste. And you're going to get the same exact answer. Now the cumulative one always goes from 0 to a stopping point. So you have to be careful. If I say less than 3, which ones do I want? 0, 1, 2, and that's it, right? Less than 3. So if I use the cumulative one, what will my X value be? 2. Now, you can also use your complement case with this. If I say more than 4, I want these guys right here, more than 4. So instead of adding them up, I can, in my calculator, do 1 minus my 4 or less. That's your complement case. So try it. Put 1 minus, and then do your binomial thing, and see what you get. Oops, it might not work with the 1 minus. You might have to say 1 minus 0.951. So I can do it this way, and subtract it from here. This is your complement case. Your cumulative is nice. If you're going to do this once or twice or whatever. If we're going to do a lot of them, then we're going to do the table. The nice part about the cumulative is sometimes you'd have to do like up to 100 of these. You don't certainly want to have a table for 100 of them. So you'd rather do it in your calculator. Accumulate it up to 1 point and then subtract it from 1 if you need to. And we'll look at an example in a second. Everybody good with this? Okay. Now, here's a good example of what I was just talking about. The results of a recent survey indicate that 58%, there's my P, of all households own a gas grill. I surveyed a bunch of people and 58% said they own the gas grill. Now I randomly select 100 people and I ask them, N, do you own a gas grill? They either say yes or no. 2 choices. I want to know what is the probability that exactly 65 households will own a gas grill. So I put this in my calculator. Binomial PDF, this is my exactly. 100 is my N, my P, my X. I certainly don't want to make a table for 100 things, right? I'm only going to need to be asked 1 or 2 things. so I don't want to make a table for this. You'd be there a long time. All I need is this one. Now, I ask, what is the probability that fewer than 40 will say yes? Will say yes, they own a gas grill. Fewer than 40. So I want to do this table 39 times. So this is where you'll use your cumulative. You'll put it in your cumulative PDF. You're still going to have your 100. You're still going to have your 58. And what number should I use as my cutoff? 39. I want fewer than 40. Okay? All I need to do this is once. I certainly don't want to make a table with all those entries. I could also ask this. What is the probability that more than 70 say yes? I want you to think about this and tell me how I'll do this without having to do this 71, 72, 73, 74. What do you think, Kev?
You do it with 69 and then you just roll minus.
Okay, so we can do a binomial CDF. You're going to put 100.58 and up to 69. We want more than 70. So the opposite, its complement, is less than 70. Kevin says go up to 69. Find that part of your table, and then subtract it from 1. That will give us the other part of it. Because you certainly don't want to have to go through this whole thing and do it a number of times. Right? Your complement case is a good case to use. A lot of you kind of a little forget about that or struggle with that. You use your complement when you find your Q. You find P, you do 1 minus Q, you find Q. It's everything but that. So you find like a halfway mark. I'll go up to here, then I'll do the 1 minus this. Okay? So I need you to give me an answer. Everybody work out this problem. The probability that more than 32 say yes. Work this out. You need to make a table, then you're going to need to make a very big table. You think it's going to be a small number or a large number? It's going to be large. Why? What's your probability at? 58%, which is more than half of your people, right? More than half of your people, every time you ask them, are going to say yes. So if I'm asking for more than 32, that falls under half my people, doesn't it?
Yes.
So I have a very strong probability that I'm going to get a good yes on this. You got something similar.
Well, similar to our both wrong answers.
You're both wrong answers? Anybody come up with the right answer? Anybody come up with an answer? 0.9. How many nines? A lot. 3, 6, 7. Okay. It's a very small probability that less than 32 said yes. Because your probability is at 58. So you did your binomial CDF. And what was the cutoff for X? 31. So all you want to know is If I'm looking for less than 31 to say yes, it's very small. Because I figured most of them are going to say yes. More than half are going to say yes. That's a scientific notation number. E to the negative 8 means you have to move that decimal 8 positions. So you're going to get 7 zeros in front of that 4. Yes. Uh-huh. Yeah, no, look. So you e to the negative 8? Okay, let's say watch. You're going to move that 8 positions. So it's going to be 7 zeros to 4.
That's why I looked
It's
at
the 1
it.
minus that.
Now it's here.
It's that. 1 minus.
Right.
Because you're accumulating. So if you want, here's 30, 31, 32. You want more than 32. Oh, you want more than 32. You got to cut it off at 32. Yes, you do. You got to cut this off at 32. But you want more than 32. So you want it to be 33 and above. Good call. 33 and above. So I want it to accumulate from here to here. So let's see what your 32 is. Your 32 is. It probably won't be that much difference because you're talking small numbers. But a little bit different. 7. So it's going to be 1 minus 0.12345 137. 138. It's going to be 1 minus that. Good call. Do you guys see what we did? More than 32 starts us at 33. A good way to do it is print out that little bit of your table, but don't do all the answers to it. Just print it out and you can see which way you're going with this. Okay? You be careful with your calculators, guys, because you're missing the part that if it does this side right here says move this. This is 10 to the negative 7. It's a scientific notation number. So you've got to move this 7 positions, which means 6 zeros. Now, we want the opposite of this table. So we want the 1 minus this. Okay? It's still a very, very strong probability that they will say yes. Okay? The cumulative is nice to do if you're doing 1 or 2 things and you have a large table. Most of the time we're going to be working off the table and just playing around with our tables. And when we get into a higher one, we're going to change the formula a little bit. We're going to do a different probability with it. But are you guys okay with this? All right, with where this is coming from? All right, tomorrow we're going to continue on into the rest of this. We'll do your table, we'll set up exactly 2, exactly 4, and we'll take a little stronger look at this. So